Okay, May, June 2024, paper 4, variant 3. Question 1. A ball of mass 130 grams is launched at a velocity of 14 meters per second, decelerates until it is at rest at a height of h above the ground. Define deceleration. Define deceleration. So it is the what's deceleration? It's the rate of decreasing velocity, you can say, or you can say it's the negative acceleration. Okay, rate of change of velocity, but you need to say that this velocity is actually decreasing. Rate of change of decreasing, okay, decreasing velocity. Okay, it's basically decreasing or negative acceleration, or you can say it's the negative rate of change of velocity. Okay, you can whatever you'd like, but just don't say rate of change of velocity. Rate of change of velocity would be acceleration. To be more accurate, we need to say that it is decreasing velocity. The acceleration of free fall is 9.8 meters per second. Show that the time taken for the ball to reach height h is 1.4 seconds. Can I find the acceleration, or can I find the time? Yes, I can find the time. How can I find the time? Acceleration equals v minus u over t. Basically, v minus u, or the change in velocity, is what? It was 14 and it came to rest. 0. So 14 minus 0. So the acceleration is 9.8 and 14 minus 0, which is just 14, divided by t. So basically, t equals 14 over 9.8. 14 divided by 9.8 is, yes, 1.4 seconds. Can I find h? Ignore the effect of air resistance. Can I find it? Yes. I actually do not need the mass. This question, you do not need the mass. Why don't I need the mass? Because kinetic energy would be equal to gravitational potential energy. Half mv squared is equal to mgh. If you want, you can use the mass, but I can just remove it. It would be much easier. So half v squared, which is half 14 squared, equals g, which is 9.8 times height. Find height. It would be 14 squared divided by 2 times 9.8. What is 14 squared divided by 2 times 9.8? 10 meters. 10 meters exactly. The ball is dropped from the top of a tall building. Describe and explain the motion of the ball as it falls downwards. As the ball falls downwards, consider the effect of air resistance in your answer. In C, we ignored air resistance, but in D, we need to consider the effect of air resistance. So initially, when the ball is dropped, what happens? It falls with a constant acceleration. So initially, it falls with a constant acceleration. As it speeds up, as the speed increases, what happens? The air resistance. You have to say that the air resistance increases, and therefore, when the air resistance increases, what happens? Air resistance increases the resultant force. The resultant force on the ball decreases. Resultant force on the ball decreases, resulting in a decreasing acceleration. So the acceleration decreases, and therefore keeps on decreasing. The acceleration keeps on decreasing until the weight becomes equal to the air resistance. Zero acceleration at that time. Zero acceleration at that time, which means that the ball is falling with a constant speed. The ball is falling with a constant speed or a terminal velocity. Okay? Hmm. Figure 2.1 shows a solar-powered traffic warning lights. Okay, name the energy stored inside the battery. It is chemical energy. The two lights are connected in parallel. State one advantage of a parallel connection. One very important advantage of a parallel connection is that if one of them breaks, the other is unaffected. Okay, if one lamp breaks, the other is unaffected. The efficiency of the solar cell is 22%. The power supplied to the lights is 15 watts. State what is meant by 22% efficiency. What is meant by 22% efficiency? That the output is only 22% of the input. The output, or instead of saying the output, the useful output, okay, the useful power output is only 22% of the total power input. It's only 22% of the total power input. Can I find the total power input? Yes, I can find the total power. The power supplied by the lights is 15 watts, so this is the output. This is the output. So basically, efficiency equals useful output over total input. To find the input, it would be output over efficiency, which is basically 15 over the efficiency is 22%. Write it down as 0.22. What is 15 divided by 0.22? 68 watts. 68 watts. Suggest two advantages of using solar cells to power the traffic lights compared to using the mains electricity. Mains electricity, the electricity being supplied by the government. What are two advantages of using the solar cells? So you do not need to, okay, you do not need to depend on the main supply. You can build them in very, let's say, remote areas. It's not affected by the power cuts, for example. So it is not affected by the power cuts. Okay. You can also say, for example, let's say that you can build them. Okay, you can have these power lights in very remote areas. Okay. Okay, have the lights in very remote areas. Figure 3.1 shows two children balanced on a seesaw. Okay. State why the seesaw rotates clockwise. Child B moves. Now they are in this position. Uh, um, they are balanced. If child B moves a distance of 0.05 meters away, moves at a distance of 0.05 meters in this direction, explain why the seesaw rotates clockwise. Why? Because the moment has increased. It has increased. The clockwise moment increased due to the increase in as the distance increased. Child A puts a backpack on the seesaw, okay, and it now balances. He has a backpack, and it now balances. Calculate the mass of the backpack. Okay. Okay. We need to find the mass of the backpack. Basically, we need to find the weight of child A and this backpack combined. Now, what should I do? Basically, I will solve the question quite simply, saying that the clockwise moment is equal to the anti-clockwise moment. Okay. Clockwise moment equals the anti-clockwise moment. The force or the weight of child B is 900 newtons. Weight of child B is 900 newtons. And the distance of child B isn't zero point 0.8. It's not 0.8. What is the distance of child B? Yes, it is 0.85. Why is it 85? Because the distance has increased by 0.05 meters. So the distance has increased, so the distance is now actually 0.85. The anti-clockwise moment of child A, we need to find the anti-clockwise moment should be equal. Yes. What is the force? I need to find the force. First of all, I need to find the force times the perpendicular distance, which is 1.6 times the perpendicular distance, which is 1. Can I find the force? Can I find the total combined weight of the child and the backpack? Yes, I can find it. So just divide by 1.6. 900 times 0.85 divided by 1.6 is what? Is 478. So the total force is now what? 478 newtons. Can I subtract the weight of the boy, of child A? Yes, minus 450. Minus 450. So the total weight or the total force of the backpack alone is 28 newtons. Can I find the mass? Yes, I can find the mass. Mass equals weight over g, so it's 28 divided by 9.8. When you divide by 9.8, the total mass would be 2.8 or 2.9 kilograms. This is the total mass of the backpack on its own. 2.9 kilograms. It's a very neat question. Concrete floor under the seesaw is replaced with a rubber floor. A child falls from the seesaw and experiences an impulse. He experiences an impulse. Define impulse. What is impulse? What is impulse? It is the change in the momentum. Or you can say that it is the force times the time. You can say either. Okay, so it is the change in momentum, or you can say that it is the force times the time. Explain how the rubber floor reduces injury to the child. Use ideas about impulse, force, momentum, time in your answer. How does it do that? When the child hits the floor or hits a rubber floor, what happens to the time of impact? Think about it. What happens to the time of impact. Time of impact increases. The time of impact increases. When the time of impact increases, what happens to the force on him? The force decreases. Force decreases. Force decreases. The force decreases. Why? Because it's the for the same change in momentum. Change in momentum. Or you can say for the same impulse. For the same impulse, F times force times time equals mb minus mu, change in momentum. So basically, if you increase the time, you will decrease the force on him. Figure 4.1 shows a stainless steel saucepan. State what happens to the water particles as the temperature increases. As the temperature increases, what happens to water particles? They gain kinetic energy. They gain kinetic energy. They move faster. The saucepan contains 250 centimeters cubed. The specific heat capacity is 4,200. The density is 1,000. Show that the mass is 0.25 kilograms. Okay, we have the density, we have the volume, but take care that the volume is 250 centimeters cubed. You need to divide. Okay, you need to divide by 100 cubed. Mass equals density times volume. 1000 times the volume, which is 250, but this 250 you need to divide it by what? You need to divide it by 100 cubed. 100 cubed, which would definitely give you 0.25 kilograms. Okay, Calculate the energy required to increase the temperature from 20 to 65. How can I increase the temperature from 20 to 65? Yes, E equals mc delta T. The mass is 0.25 kilograms, the C is 4,200, and the delta T is 45, which is 65 minus 20. What is 0.25 times 4,200 times 45? This is 47,250 joules. So you can just write it down as 47,000 joules, or 4.5 times 10 to the power of 4 joules. 4.7, I'm sorry, times 10 to the power of 4 joules. The heater supplies enough power to heat the water in 39 seconds. The student matches the time taken to heat the water as 115 seconds. So just why the actual time taken to heat the water is longer. Whenever he talks about a longer time taken or more energy actually required, we have to say that, or we have to assume that a lot of the energy is lost to the surroundings. Okay, some of the energy, okay, is supplied or is lost to the environment. The stainless steel saucepan is replaced with an aluminum saucepan. Specific heat of the stainless steel is 500, aluminum is 890. Explain why or how using an aluminum saucepan will affect the time taken to heat the water. How will it affect it? Basically, you need to say that it will take a longer time. Why will it take a longer time? Because of the specific heat capacity. When you have a higher specific heat capacity, okay, specific heat capacity, it will take a longer time. It will take a longer time due to the higher specific heat capacity. Okay. Figure 5.1 shows two containers, each filled with hot water. The outer surface of the metal container is hot. State and explain how the electrons transfer thermal energy through the metal of the container. Again, metals, they have electrons. What do these electrons do? They are free moving electrons. Free moving electrons gain energy from the hot water. Okay, from the hot water, move freely. They move between the atoms of the metal and conduct or transfer energy. Transfer energy by bumping into the atoms. When they collide with the atoms, instead of bumping, you can say by colliding, okay, with the atoms. It would be a more professional way of saying it. By colliding with the atoms. The outer surface of the non-metal is much cooler than the outer surface of the metal container. Explain why non-metal conducts thermal energy less well than a metal. Why? Because it has no free moving electrons. No free moving electrons. Gains. Why is that? Gains electron. Explain in terms of particles why gases are more or are poor thermal conductors compared to non-metal solids. So gases are even worse conductors of thermal energy. Why is this so? Yes, because of the distances between the gases. You have large distances between the gases. You have large distances between the gases, which causes them to collide less frequently. Okay, they collide less frequently. So large distances between the gases causes them to collide less frequently. You might say there is no vibration, no lattice vibration between the molecules. Figure 6.1 shows a thin converging lens used to produce a magnified image. Explain the meaning of the terms principal focus and focal length. Principal focus. The rays are focused. Yes, the parallel rays. Okay, after they have passed through the lens. After they have passed through the lens point at which the parallel rays are focused, or you can say converged, after passing, okay, after passing through the lens, through the lens. What is the focal length? This is a distance. Okay, it is the distance between the focal point, between the principal focus, between the principal focus and the center of the lens. On figure 6.1, draw the magnified image of AB. Show your working. Magnified image of AB. How can I draw the magnified image? Basically, you need to draw the two lines. First of all, the parallel ray will pass. You have to draw it very carefully using a thin pencil all the way to the lens, and then it will be converged to the principal focus. The second line will pass through the center, and quite obviously they will not meet on the right hand side. You need to continue these rays. You need to stretch these rays backwards. Okay. Okay. When you pull these rays backwards this way, they will meet. Okay, somewhere. And then you need to draw the image. The image will be magnified upright and okay. This is the image. It has three properties: upright, magnified, and virtual. Figure 7.1 shows two charged metal plates. X marks the position of the center of the space between the plates. Anyway, on figure 7.1, draw at least four field lines. At least you can draw more if you'd like. Okay, to show the direction of the electric field. The direction of the electric field will be from the positive plate to the negative plate. So we need to draw four lines pointing downwards, equally spaced. Please draw them equally spaced as much as possible. So for example, I'll draw a line and then I'll leave, for example, 1 centimeter, whatever you'd like. Okay, please draw them equally spaced, even if it passes through X, right through X, okay? But they have to be equally spaced. He said at least four, so you can draw more than four lines. Describe the effect on a negatively charged particle at X. If you have a negative particle at X, what will happen to this particle? Yes, it will be attracted upwards. Okay? Attracted upwards towards the positive plate. Okay, during a thunderstorm, an electric field is set up between a cloud and the ground. The lightning shown in figure 7.1 discharges an amount of 2800 amperes for 0.012 seconds. Can I find the charge? Yes. I equals Q over T, or Q equals IT. So 28,000 times 0.0012. 28,000 times 0012. 33.6 33.6 coulombs. Do not forget the unit. 33.6 coulombs. Lightning transfers 1.2 times 10 to the power of 8 joules of energy. Calculate the potential difference. Can I find the potential difference? Yes, you have E equals VIT, right? E equals VIT. To find the voltage, or you can say that E equals VQ. Basically, you can say that E equals VQ, which is the same because IT is Q. Can I find the voltage? Yes, the potential difference would be equal to E over Q. The energy is 1.2 times 10 to the power of 8, and Q is 33.6. 1.2 times 10 to the power of 8 divided by 33.6. This is a huge number. It's 3.6 or 3.57. 3.57 times 10 to the power of 6 volts. Times 10 to the power of 6 volts. 3 million volts. Hmm. Figure 8.1 shows images produced during two different medical scanning procedures. Define ultrasound. What is ultrasound? It is a sound with a frequency. Sound with a frequency above 20,000 hertz, 20 kilohertz. State how the speed of sound in liquid compares with the speed of sound in air. In liquid, it is much greater. In liquid, it is much faster. 1,500 meters per second. X-rays are part of the electromagnetic spectrum. State the speed of X-rays in vacuum. It is 3 times 10 to the power of 8 meters per second. Describe three similarities or differences between X-rays and ultrasounds. X-rays and ultrasound. You can say one similarity between them is that they both pass through the human body. Right? They can both pass through the human body. Okay, let's write them. Both pass through the human body. You can say that the X-rays are used. Okay, X-rays show the bones, while the ultrasound shows soft tissue. Okay, while ultrasound shows soft tissue, such as babies, for example, or any other small organs. A third difference between them would be that the X-rays are much more harmful. Why? Because they are part of the electromagnetic radiation. Okay, X-rays are more harmful, or actually harmful. Ultrasound is not harmful at all. Okay, because of the radiation. It produces some radiation. The high frequency, the very high frequency of this electromagnetic radiation. Hmm. Question 9. Figure 9.1 shows a mobile phone being charged on a wireless charger. Wireless chargers. When the charging plate is switched on, there is an alternating current in the primary coil. A secondary coil is in the mobile phone. Explain how the current is produced in the second. Okay. So how's the current produced? Basically, we need to talk about a transformer. How does the transformer operate? Okay, so the alternating current in the primary coil produces an alternating magnetic field, which you have to say that which cuts, okay, which cuts the secondary coil, secondary coil, producing an alternating induced EMF, inducing an alternating EMF and current. Primary coil, alternating current, produces an alternating magnetic field, cuts the secondary coil, inducing a current and EMF. The maximum energy stored in the battery is 0.12 kilowatt hours. Okay, kilowatt hours. Show that the maximum energy is 4.3 times 10 to the power. How can I show that the maximum energy is this amount? Basically, we need to say that this is energy. 0.012 kilowatt hours is actually energy. How can I show that the maximum energy is 4.3? So you need to multiply. You need to multiply. Basically, kilowatt hours, you need to multiply by 1000 and then multiply the hours. So energy equals power times time, which is 0.012 times 1000 because kilowatts, because of the kilowatts, and then 60 and 60. 0.012 times 1000 and then multiply by 60 and 60, which is 43,000, okay, 43,200 joules, which is equal to 4.3 times 10 to the power of 4 joules. Charging plate has a useful output power of 15 watts. The phone manufacturer claims that the battery can be charged 50%. 50% of its capacity in less than 30 minutes. Show that this claim is true in less than 30 minutes. Can I show that the claim is true? Okay, let's see. If it has a useful output power of 15 watts, maximum stored is 0. Or is 4.3 times 10 to the power 4. In 30 minutes, what is 30 minutes? This is actually, you can multiply it by 60. Okay, you can multiply it by 60, which is 1800 seconds. Show that this claim is true. What should I do? So you have efficiency, right? Or it has a output power of 15 watts, and we want to find the 50%. What should I do? If you think about it very carefully, very slowly, it might seem to be a bit tricky. It might seem to be a bit tricky, but it's actually not that tricky. It is actually not that tricky. Why? Because you have the energy. You have the energy, which is 4.3 times 10 to the power of 4. This is the energy. Power equals energy over time. This is the energy. So time equals energy over power. Time equals energy over power. So it's basically 4.3 times 10 to the power of 4 divided by the power, which is 15 watts. If you divide by 15, this would give you 2,880 seconds. This is the total time for one full charge. This is the total time for one full charge. He's saying that 50% capacity will take 30 minutes. So 50% capacity means that I need to divide by 2, divide by 2. This is what, divide by 2, this is 1,440 seconds, 1,440 seconds. In minutes, if you divide this by 60 again, this would be 24 minutes. So divide by 60, this is actually 24 minutes. So 24 minutes, which is less. Yes, this is definitely less than 30 minutes. So the claim is true. The claim is definitely 100% true. Leaks in underground water pipes are detected using radioactive tracers. So the counter reads 382 counts. Before the radioactive tracer is added to the water, the detector measures the background radiation, which is 26 counts per minute. Define background radiation. What is background radiation? It is radiation produced by things around us, by natural sources around us. Okay? Produced by natural sources around us. Suggest one source of radiation that may make a significant contribution to the background radiation. Natural sources around us, such as what? Food and drink, for example. Food and drink. You can say the rocks, the buildings, right? Radioactive tracers added to the water. The counter shows that the count rate is determine the count rate due to the tracer. Can I find the count rate due to the tracer alone? Yes, the count rate due to the tracer alone would be the count rate on the reading minus the background radiation. So basically 382 minus 26. Minus 26, which is 356 counts per minute. Okay. Suggest which radioactive emission, alpha, beta, or gamma, is suitable for detecting the leak in the water pipe. Explain your answer, alpha or beta or gamma. So, alpha is definitely wrong. Alpha is 100% wrong. Why? Because the alpha wouldn't even be able to pass through the water itself. Would beta be correct? Yes. Let's say why. So, if I say beta, for example, why is beta suitable? Beta can pass through the soil. For example, the water pipe is underground, so the beta can pass through the soil. Okay, beta will be able to pass through the soil. Alpha cannot. Okay, can pass through the soil if there is a leak, if there is a crack in the pipe, but will be stopped. Okay, it will be stopped if there, okay, is a is no crack, for example, is no crack. Okay, if there are no cracks in the pipe, the gamma would pass through the pipe either way, would pass through the cracks either way. If there is a crack or if there isn't a crack, the gamma radiation would pass either way. Okay. Explain why the radioactive isotope must not have a very short half-life. If it has a very short half-life, we wouldn't be able to detect it. Okay? No time to be detected. No time to be detected if the half-life is very short. Okay, if the half-life is very short. Explain why the radioactive isotope must not have a very long half-life. So if it has a very short half-life, we won't be able to detected. If it has a very long half-life, then the water will be water will be harmful, or you can say it's contaminated. Okay. Last question. Question 11. A galaxy is approximately 1.2 times 10 to the power of 26 meters from the Earth. Huh. The wavelength of the observed light is longer. Longer. What does longer mean? What is this effect? It's called the red shift. State the current estimate for the Hubble's constant. Guess 2.2 times 10 to the negative 18 per second. Okay, per second. Or 1 over s, or s to the negative 1. Can I find the speed? Yes, I can find the speed. Why? Because speed equals h naught times the distance. So the h naught is 2.2 times 10 to the negative 18, and the distance is 1.2 times 10 to the power of 26 meters. You don't need to convert, so the speed would be quite fast. Yes, 2.6 times 10 to the power of 8 meters per second. Yeah, 2.6 times 10 to the power of 8 meters per second. Scientists have measured the speeds at which the distant galaxies are moving away from the Earth and the distances from the Earth. These measurements suggest that all the universe was once at a single point, right before the Big Bang. State and explain why. The whole thing is that the distant galaxies are moving at higher speeds. Okay, the further you go away, the faster these galaxies are moving. So therefore, this universe is now expanding, meaning that if we go back in time, okay, the galaxies will be much closer if we go back in time. So you need to say that the universe is expanding. Why? Because the further galaxies are moving away at faster rates, at faster rates, or at faster speeds. Instead of saying rates, you can say at faster speeds, indicating that they were once much closer. Okay. Okay.